ions here, and we're going to add some sodium hydroxide. Dropwise at first. And we can see we have a white precipitate. So we'll discard some of this because we have to now add in excess to see if this precipitate will dissolve. And we're seeing that the precipitate is remaining, it is not dissolving. So now we're going to move on to the test with aqueous ammonia. So we're going to add, once again, dropwise at first. Alright, and we're seeing that no precipitate has formed. So if no precipitate has formed, it means we don't have to see if something will dissolve in excess. Next, we're moving on to zinc. And as you can see, all of these ions are colorless. So we have to give that observation. So once again, sodium hydroxide, dropwise at first. Okay, so we see we have a precipitate form. So adjust a little at first. So we see a thin precipitate has formed, a thin white precipitate has formed. So now we have to see if this precipitate will dissolve in excess. So once again, we can throw some of this away so we don't have to use up too much sodium hydroxide to cause it to dissolve. We can see that the precipitate is dissolving to give a colorless solution. And if I added more sodium hydroxide, it would dissolve even more, but we get the idea. So now we're going to move on to zinc and the test with aqueous ammonia. So once again, dropwise, so just a small quantity. So we see we have our white precipitate once again. So let's see what happens in excess. So let's just throw a little out. Not too much. So now we're going to add aqueous ammonia in excess. So it's dissolving in excess. So if we add enough, this will eventually look very colorless. So next we're moving on to lead.
Cation test, aluminum and lead, take 1.
Okay, so now we're moving on to lead ions. And we're going to once again run the test with sodium hydroxide. So as before, we're just going to add dropwise and look to see if we're going to get a precipitate form and then make note of the color. So as we can see, we have a lovely, nice white precipitate here. So now we're going to see if it dissolves in excess. So let's throw some of this out. All right. Okay. So let's drop some more. And as we're adding in excess, we have a feel whether it's going to dissolve or not. So this is dissolving. Now it will dissolve eventually if we add in enough sodium hydroxide. Yes, there we go. Very good. So now we're going to move on to lead. and aqueous ammonia. Once again, as before, dropwise, so a small quantity. Because with this small quantity, we want to see if a precipitate will form or not. So there we have it, a nice white precipitate with aqueous ammonia. Let's see if this precipitate will dissolve in excess. Does not dissolve in excess. So with lead, lead 2 plus ions, the white precipitate formed with aqueous ammonia does not dissolve in excess. So now we're going to run the same series of tests again with aluminum ions. So now we're going to run the same set of tests again with aluminum ions. So sodium hydroxide, a little bit at first, dropwise. So there's our white precipitate. Okay, so let's see if it dissolves in excess. Yes, it does not dissolve in excess. Okay, let's add in excess. And the white precipitate is dissolving in excess to form a colorless solution. So let's see now what happens with the aluminum ions and aqueous ammonia. White precipitate and dropwise. Does it dissolve in excess? So the white precipitate does not dissolve in excess aqueous ammonia.